Okay, ITS128. Today's April 4th, and we are starting Chapter 8 today, Strings and Structures and Enumerated Types. And so today I'm just going to be going over the slides for maybe the first half of the slides. See, this is covered 3 days. We're going to spend 3 days on this. Strings is important. Structures are sort of important, not that important. Enumerated types are pretty important. Strings are very important though. So let me share my screen. And put this over here. And let me download some PowerPoint slides, Chapter 8. And let me save them down on my special place that they give me here, Chapter 8. So topics for this chapter: string and character processing, structures, enumerated types, and image list control. The image list control. So in this chapter, we're going to discuss various string and character processing techniques, which are useful in applications that work extensively with text. I think I do more string processing in my day-to-day programming than really anything else. Structures are a good way to encapsulate several variables into one single item. It's kind of like structures are kind of like classes, except for there's no methods involved. Back before we had classes, back before we had programming languages that had classes, the thing about a class is that the fact that that you can have methods as members. Methods, of course, are little programs that operate just on the variables that are inside the structure. Structures are just encapsulate variables themselves, and then enumerated types are just it's another way of if you want to have a variable that can take on different values, not just 1, 2, 3, 4, 5, but you want to have a variable that can take on the value red, green, blue, orange, yellow, let's say, like colors. And you want to be able to say if something is equal to yellow or if something is equal to red. Basically, enumerated types is just a mapping into 1, 2, 3, 4, 5 sort of thing. But of course it's a much better way of keeping track of stuff and writing code that is much easier to understand. And then the image list control is simply a control that it's a data structure for storing and retrieving images. Don't use that too often. I don't use that too often. All right, string and character processing. Text, let me switch over to my slideshow here. So text is a commonly used form of data to be processed in programs, and we frequently need to manipulate strings at a detailed level. One reason strings are so important is because you always start with some interface with the user. Programs always start with some interface with the user, and the interface between the computer and the user is always strings. When you have an application where you enter in some numbers, you're really entering in strings, and you got to have something in there to convert the strings to the numbers. But more complicated programs like a compiler, like Visual Studio or whatever, you have a program, you have a C# program, and the compiler has got to convert that into the ones and zeros of the microprocessor program. And it's got these words and letters and stuff that make up your program, the semicolons and the string and the plus minus, curly braces, all that kind of stuff. There's something inside the compiler called the parser that parses all those characters that make up your program and converts them into something that it understands and converts it into your program and so on. So that's all string and character processing. C# and the .NET framework provide tools to work with for individual characters and for sets of characters, which are, of course, strings. And so we have this character data type, which is it's used to store individual characters. A char variable can hold only one character at a time, and it's declared with a char keyword. We've seen string, we've seen int, we've seen a double, and we've seen decimal a lot. There's char. Char is just a single character, and so this statement here declares a character, a character type variable can hold one character, and here in this case it's named letter. That's the name of it, and the way you assign a character to this variable called letter is you use single quotes. Single quotes. String uses double quotes. This character uses single quotes. In every other programming language, there's no difference between a double quote and a single quote. And in every other programming language, there's not this individual character type. There's only string types, and a string can be one character, but it's still a string. In C#, it's more restrictive, and there's reasons for it. And so one way it's able to distinguish between a character type and a string type when you're assigning a variable to a value is by using single quotes versus double quotes. And so in this case here, we're assigning the letter, the single character G, to the variable letter. A char and a string are two incompatible data types. The following attempts to assign a string to a character will not work. So you cannot assign the letter G to the character variable letter using double quotes. Does not work. You have to, and if you want to display out if you want to display out a character, want to display it out, you have to use toString because a message box show has got to take a string as the argument, and a character is not a string, so you got to use the toString method there to do that. And C# allows you to access the individual characters of a string by using this subscript notation. So this is convenient. It can be confusing. It's convenient though. It's if you have a string, and the name of the string is called name, and it equals these 5 characters here using double quotes, so it's a string. And then you have another variable called letter, and so what you can do is you can loop from 0 to 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. You can loop through, and you can say you can assign this variable letter to each character one at a time like this and display it out. So this is going to first display up a J, capital J. Then after that you have to click OK. Then it'll display out a lowercase a. You got to click OK. Then it'll display out a C. You got to click OK, and so on. You can also use for each. That works. For each letter in this variable, in the string variable, same thing here. Displays it out one letter at a time, one character at a time. However, when using subscript notation, the characters in a string are read-only. For example, the following will not compile. I think they put errors in these PowerPoint slides on purpose to make sure that I'm paying attention. So this will not work. You cannot change this J to a T this way. You can't do it that way. It's an error. There's a bunch of methods available to test to test different things, and so there's this static class char, and this will test to see if this ch variable here, it's got to be a character variable. It tests to see if it's a digit. If ch is a digit, in other words, if it's 0 through 9, this is going to return true, the value true. Otherwise, it'll return the value false. You can also do the same thing by if your argument is a string, you can include an index which will identify a particular character in the string. Index starting with the number starting with 0. It'll identify a particular character in the string, and and it does the same thing. It will return a true or false if that particular character is a digit, is a 0 through 9. Same kind of thing if you're looking for a letter. If it's lowercase a through z or uppercase a through z, it'll return true if ch is true. Otherwise, it returns false. Same thing with this, the index of a character within a string. This will return, if it's a letter or a digit, we're very basic here, letter or a digit, it'll return a true or false. Same thing with a particular index value of a string. And there's more. So this is so here's an example of how to use it. So here we're identifying the 0th index of a string variable. Here we're identifying the 0th index of this string variable. Same thing. These two things do the same thing. There's more. There's is punctuation. It might not be a letter or a number, but it might be a punctuation, like a period or a semicolon or something. Same thing. White space might be a space, might be a tab character, might be a return character. Same thing. Same thing. Here's a punctuation mark, an exclamation point. It's the 5th one. 0, 1, 2, 3, 4, 5. Same thing. The 5th index of this string variable here. This is the 0, 1, 2, 3, 4, 5, 6. This is wrong. This should be 5. All right. There's more. This will return true if ch is lowercase versus uppercase. It's got a lowercase letter or an uppercase letter. This is a same thing. It's the index character of a string. Uppercase letter, same thing. This is a lowercase letter. This is an uppercase letter. We can convert. So Now we're getting into methods that don't return true or false, they return something else. These return characters. So this takes whatever this is, and if it is a lowercase letter, it's going to return an uppercase letter. If it's an uppercase letter, it's going to, no, I'm sorry. If this is an uppercase letter, or if this is an uppercase letter or a lowercase letter, it's going to make it lowercase. Same with this, it'll make it uppercase. This doesn't really make too much sense here, but I think this is a major error here. Some tasks require you to search for a specific string of characters within a string. Now we're getting into the good stuff. Some of the substring searching methods are, for example, let's say you've got a string variable, and you want to know if this string variable contains this substring. And so this here returns true or false. I said something to make my Siri act up here. It's weird. Did I say something Siri?
It's usually hasty.
Yeah, but I must have said, the sentence that I said must have contained "Hey Siri," because this thing popped up. Here we're looking to see if a string variable contains a character. So you can put a character in here if you want to, or a string. Here, this checks to see if the string variable starts with a particular substring, returns true or false. This method here if this particular string variable ends with this substring, then this will return a true. And so this particular example here's a string variable, and this tests to see if that string variable contains the string ICE, and it does. This one returns, this can be a string or a character. Returns a true if it contains an I, it does. This returns, this is not going to be true. This is not true because EAM is not the, it doesn't end with EAM. It ends with EAM EAM exclamation point. So this is. Sometimes you need to know the position of a substring. So you can use index of methods. This is, okay, by the way, these methods are not found in any other programming language that I know of. This is not found in any other programming language I know of. But this is found in every other programming language I know of, pretty much. All the newer ones, index of. So this is going to return the index of the first character of that substring. So it returns the integer position of the substring's first occurrence, and returns -1 if it's not found. Common usages of this to find substrings are this, where you have a string variable and it's looking for the index of the substring. So it's where, you know, it's the index of the first letter of the substring. What this does is this gives you a starting point. So it doesn't matter. It's not going to look before this index. Okay, so this is useful if you want to find, you know, you're looking for more than one occurrence. You want to find the first occurrence, and you get back some index value, and then you can put that index value right there and do this thing again, and it'll continue on from that particular from the first one. You see, if you want to search through a whole big document to find the first occurrence and then the second occurrence and the third occurrence, you find the first occurrence, and let's say that's at index 50, and then you do it again and you start at 50 or 51, and it'll look from there on, and it finds another one maybe at, you know, 200 or something, and then you can do it again. And then this, you can there's a third argument here, third parameter, which will limit it. So this defines a range. This defines a range. It's going to define a starting point and then a number of characters in a range. So these are the three different versions. Start is an integer containing a starting position. Count is an integer specifying the number of character positions to examine. So the following code displays 10 because you're looking for the index of ice. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, this is correct. So if the position is not equal to -1, if it returns something that's not equal to -1, then it's going to be something, and it'll display out where it is. So this thing displays out a 2 because it's looking for the first occurrence of CO, and so the first occurrence of it's going to find the first occurrence of CO after the second. Starting with the second index. So it's going to skip this, it's going to skip this, and it's going to start with the second index and look for the first occurrence of CO, and there it is. It's right where it starts. It's at 2. So that's why this displays out 2. And this is going to display out 6 because it's looking for the first occurrence of XX after the third index. So 0, 1, 2. So then it's going to look for the index of that. So it's going to be 0, 1, 2. No, it's going to be 0, 1, 2, 3, 4, 5, 6. So this is the XX starting with the third index. The first occurrence of XX starting with the third index is at the 6th index, this is the 6th index right there. And it looks 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. Here's some more examples. Following code will display 2. So we got this string chocolate ice cream, and we want to find the integer position of the index of O. That would be here. So that's the 0, 1, 2. It's the second index. So that's why it displays out 2. This is going to display out 4 because it's going to look for the first occurrence of O starting with the third index. So 0, 1, 2, 3, starting with 3. And then so this one, index number 4, is the first occurrence of the O. So that's why it displays out a 4. And here we're going to, this displays out 12. Why? Because we're going to look for the first occurrence of E after the 10th, or starting with the 10th index. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now where's the first E after that? 11, 12. There it is, 12. Finding positions of substring backwards. When you need to search backwards to find the last occurrence, you can use the last index methods, and this is also available in you aren't really searching backwards. You're really looking for the last one. You aren't looking at the string in reverse. You're just starting at the back end, or looking for the last one of them. So it returns the index position of the last occurrence of a specified character or substring within this instance. So common usages are this. So here we're finding the last index of substring. So that just means if there's more than one, it's going to give you the last one. If there's more than one, it's going to give you the last one, so on. You can also find characters. It's the same kind of thing. Same thing. So again, this defines a range, and it's going to return the last index of it. So this is going to display out 11. Why? So find the last index of blue. So it's going to be this is the last index of blue right here, and so that's going to start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is going to display 6 because it's going to look for the last index of XX starting at 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so it's going to look in this range right here. And why does it display 6? I think this should be 11. All right. Quite sure that should be 11. Okay, the next one following. No, this one is probably 6. So starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, I mean, how far are we going? What time is it? It's 3:50. I'm going to bring up Visual Studio, figure out the answer to this question, to these questions. So, Visual Studio. All right, let me start a new project here. Windows Forms app. Let me just view some code. Let me just double click here. Double click. All right, form handler, message box, show, flow. All right, that works. Okay, so let me put some of this code in here. I want to see what happens. I could be wrong, you know. I could be confusing my languages backwards. Where's this? Index. Oh, this is index of last. I want to find last index of. Oh, backwards. Okay, backwards. Okay, this one. Um, all right. String str equals xx space oo space xx space oo space xx semicolon. Int position equals str last index of quote xx comma 10, and if position is not equal to -1, then message box show position to string. All right, and I'm gonna do this. I'm gonna do this. XX last index of XX in XX. Oh, no, in string str is at plus that. Last index of XX in the string is at that place. Okay? 6. Oh, this is right. All right, so I gotta figure out why this is the case. So maybe we actually do go backwards. 1, 2, 3, 4, 5, 6. Starting at 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, let me do this one. 10, comma 8. I'm sure this is 6 also. Okay, so what I'm going to do now is open up the book, title source. And I'm going to go to here. And we are in chapter 8. Oh, string processing. Okay. Let me find last index. This is testing. We did went through testing. And this is the password validation application. Character case conversion. Substring position. So, okay. Blue. Modifying string. All right, let me do a search. Last index of all right, last index. Here we go. So this returns 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right. This returns searches starting at the position specified by start and proceeding backward. Proceeds backwards towards the beginning. So that's what this start value does. It proceeds backwards. So in this case, this returns 6 because we starts at 10, 0, 1, 2. Let me just copy. Well, okay, it starts at 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It starts here. Starts right there. 0, 1, 2, 3, 4, 5, 6, 7. Let's make this bigger. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It starts there and goes backwards. It goes back in this direction. So it's going to go. It finds the first occurrence of XX in that direction. So it's going to be 0, 1, 2, 3, 4, 5, 6. Okay, that makes sense. Okay, very good. Glad I cleared that up. All right, so this defines so this is going to start at 8. Oops, this is going to start at 10 again, which is this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to start at this O here, this second O right there, and it's going to do 8 characters. So it's going to go all the way back to 0, 1, or 1, 2, 3, 4, 5, 6, 7, 8. So within this range of 00 space XX space 00, find the last index of XX. So it's going to be this XX right here, which is starting at the 6th point. Okay, very good. The following code displays 14. So here we're looking for the last index of the C. So it's going to be this one, that's C from cream, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is the 14th position. And this one's going to be 12, so it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So starting from here, find the last index of E, which is this E right here, and that's in the 12th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, I start counting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So that's why it displays out 12. Same with this. It's gonna start with the position 14, which is this position. It's gonna go 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna be in this range of characters here. Where is the last E? And that'd be this E right here. That's in the 12th position. All right. Sometimes you need to retrieve a specific set of characters. So this is the substring, and this is in every language that every modern language. This is going to return a substring. So it's going to look in here, and it's going to return a substring, starting at the start index. So this returns a string containing the characters beginning at start, continuing all the way to the end. This one here is going to return a substring starting at start, and it's going to only return this many. And if this goes over, it's only going to return till the end. So this returns bean. So it's going to start at 6, 0, 1, 2, 3, 4, 5, 6. So it's going to return everything to the end. So it just returns beans. This is going to display cocoa. It's going to start at 0. Okay, so this is okay, right? So it starts at the 0th index, and it's only going to return 5 characters. So the 0, 1, 2, 3, 4. Okay, so it starts at 0, and it's going to return 5 characters. 1, 2, 3, 4, 5. So it's going to return just these 5 characters here, starting at the 0th index. So now we're getting really fancy. We can modify a string. We might need to modify the contents of a string. We can do the insert method to insert a string into another. We can remove some characters from a string. We can trim. Trim just refers to the leading and trailing spaces. This is very useful. You can trim off the return character, you can trim off a tab, you can trim off spaces in the beginning, spaces in the end. So this trim method is going to only return this. The trim method will only return this, not the space and not these spaces. Start trim removes just the leading spaces. Trim start, leading spaces, trim end just removes the trailing spaces. You can convert the cases of strings by using to lower and to other. Many languages have that. Here you can insert this string starting at this point in this variable. So let's say you got a variable here, str1, and it's new space city, and you want to insert the word York starting with index 4. So 0, 1, 2, 3, 4. This isn't right. I don't think this will work. I think it's gonna I think this York is gonna be crammed right up next to the city. Because look, there's two spaces. There's one space here, and there's two spaces here, and there's no spaces here. There's no space there. So we can say string here, string 1 is equal to new space city, and string 2 is equal to str1, str1 dot insert parentheses 4 comma York. Bet you they meant to have a space after that. And now we want to message box 2 message box show str2 see the York and the city are jammed up together. I think they mean for you to have a space here. There we go. That looks better. All right, just keeping them honest. All right. So this is going to remove where start specifies remove 7 characters. Start 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay, good. So this will just end up being jelly donuts. This text down here does not apply to this. This trims trim method. So this is going to output. This is going to just output hello. All right. Yeah. Right. So it trims off the spaces and then displays, you know, it with these two greater than and less than symbols on each side. This just trim. Yeah, this trims off the beginning, trim start. This trims off the end, same thing. When a string contains a series of words or other items, data separated by spaces or other characters, a string can be thought of to contain 4 items of data. I don't know why it says 4 items of data. When a string contains a series of words or items of data separated by some character, in this case, it's got these 3 things: apple, orange, and banana. It's separated by a colon. So we can tokenize this using the colon as the delimiter, and we end up with 3 separate things. And we use the split method to do that. It extracts tokens from a string and returns them as an array of strings. And so you can pass null as an argument indicating the white spaces are the delimiters, You can pass a character array as a list of delimiters. So in this case, we just say split. We got this variable called str, and we've got these four words here, 1, 2, 3, 4, delimited by spaces. And so if we do this, we use the split method, and we just put a null there. We should be able to put a space there too. It's going to return an array of an array named tokens. It's going to be a string array, and this string array is going to have four elements in the array. Four strings, 1, 2, 3, and 4 strings. And here we're using the semicolon as a delimiter. It looks like that. Here we're using, we can use an ampersand and a period. So, it's getting late. I'll show you that later. But anyway, this is going to split it into an array of, it's going to contain 3 elements. The first one's going to be Joe. The second one is going to be Gaddis Books. The third one is going to be com, C-O-M, because it's got 2 delimiters. Either one of these can delimit, will delimit, and the ampersand is used to delimit these don't have to be in order or anything. It's either one. But anyway, so that's how that works. Oh, is that okay? That's good. Okay, so let me just show you this as an example, and then we can be done here. So I'm gonna show you this here just to reinforce it for you. So I'm gonna say there's a string called Joe at schmo.com, and I'm going to say, I'm going to define some delimitors, a character array called delim equals this set is going to be a period and an ampersand. No, it's a at sign. You notice I changed the order. And then I'm going to say I'm going to create a new string array called tokens, and that's going to be, I'm going to take string and I'm going to split it using delims. Look at that. There should not be a 1 there. And then I'm going to do for each toke in tokens. Is that how I get these? What is let me go back to here. Yeah. Oh, I gotta declare that. Okay, so that's in. Okay, so string toke in tokens. Message box show toke. And so when this runs, oh, some errors here. Oh, semicolon. Let's run it now. So first it's going to go show Joe, and then schmo, and then com, and then we're done. So if I were to do spaces here, I could do split. Let me see if this works. Oops. Yeah, let's see if this works. Joe, schmo, com. Okay, so it does work. So you can put a space there, or apparently you can put null there. Joe, schmo, com. All right. So anyway, that's pretty good. It's actually only 4:24. This clock is 5 minutes fast. All right, so shit, I never shared my screen. Did I never share my screen? Hey, Blade, did I ever share my screen? I didn't. Doesn't look like I ever shared my screen, does it?
Yeah, I've been watching.
Can you say that again? Did I ever share my screen?
I've been watching the whole time you shared it.
Okay. All right, great. Okay, so, all right, so thanks for watching. We'll see you on Tuesday.